Okay, here's problem 19 out of the 25, so chapter 8, algorithmic question 20. And here it gives you a chemical reaction in words, and you have to just turn that into the correct formula. So dinitrogen monoxide, so we're going to have N2 dinitrogen monoxide, N2O, decomposes to form, so it decomposes to form nitrogen gas, which you know is N2, and oxygen gas, which is O2. How many grams of oxygen are formed when we're going to start with 20.0 grams of the N2O? First step here is to balance. So we've got a 2 and we've got a 2. We need to put a 2 there, right? That's going to give us our balance of O, and then we've got 4 N's, so we got to put a 2 there, and then we're balanced. So what we are given here is that we have 20.0 grams of N2O, and what we want to know is grams of O2. That's what we want. So it's going to be the same old unit conversion problem. First step is to cancel grams of N2O and go to moles, because that's what we do in stoichiometry problems, N2O. And we'll look that one up, but that cancels those units, right? And then we multiply to get rid of moles N2O. And we want to go to O2, so we go to mole O2. And that is going to be out of the stoichiometry, so there's a 2 there and a 1 there. That cancels those units. And then the last step is to cancel moles of O2 and make that grams of O2. And then you look that up, but that's 32. We know that's 32. That one's going to be 28 plus an O plus 16, so 28, 34, 44. Now I would check that, but that's 44. In fact, I'm not even going to do that calculation. The units cancel. We end up with grams of O2, and that's going to give us our right answer. So here for problem 20, over here it says, according to the following reaction, how many grams of sulfur are formed when this 37.4 grams of water are formed? And the question is, how many grams of this are formed along with it? So since these are stoichiometric related, 3 moles for every 2 moles, we can just start with what we're given here. So what are we given? In this case, it is 37.4 grams of H2O. And what we want over here are the equivalent number of grams of sulfur. Every time it hops over, it's going to make this in mole ratios 2 to 3, 2 to 3. This is some number of moles. That means it's going to produce some number of moles over here, and that's all we're doing here, making this conversion. So we're going to convert this by removing the grams of H2O, cancel those units, make that moles of H2O, because that's what we do in stoichiometry problems, and that's moles of H2O. And we got to cancel now moles of H2O and make that moles of sulfur. Here's where the stoichiometry comes into it. It's a 2 down here. It is a 3 up there. And then we want to get grams, so we have to just put down moles of sulfur and put up grams of sulfur up there. Cancel those. And then you're going to want to put the right number of grams in there, and that'll give you your answer to this problem. So here's problem number 25, or chapter 8, algorithmic question 32. That means they're going to be a little bit different on each one, but the same idea. So you're given this reaction in words, and you've got to turn that into a chemical reaction. I've already done that. So silver nitrate, you know the formula, NO3 has -1, Ag is +1, so it's AgNO3. Barium chloride, barium is +2, chloride is -1, so it's BaCl2. Forms silver chloride, Ag +1, Cl -1. And barium nitrate, barium is 2+, nitrate is -1, so it has to have that ratio. And then we're told we have 14.4 grams of the silver nitrate and 15.0 grams of the barium chloride. So this is going to be a limiting reaction type problem. You've got to calculate which is the limiting reactant. And then, because the question is how many grams of silver nitrate are formed. So I'm going to do that on the next video and stop this right here and pick it up. Okay, so the strategy for these is to calculate the amount of each reactant will make a certain amount of product, and then whichever one makes the smallest amount of the product, that's our limiting reactant. So if we take 14.4 grams of AgNO3, what we want to do is calculate how many, we're just going to go to moles of AgCl that can be made. And then we're going to do the same thing with the 15.0 grams of BaCl2, figure again how many moles of AgCl that can be made. So what we're going to do is multiply this by grams AgNO3 to cancel those units and convert that to moles of AgNO3. Okay, and then we're going to cancel moles of AgNO3 and convert that to moles of AgCl. That cancels those units. And that ratio comes from the stoichiometry, which we didn't do. We didn't balance this, right? So we have 2 chlorines over here. We need to have 2 chlorines there. So a 2 has to go in there, and that gives us 2 silvers. So we've got to put a 2 in there. So it's 2, and that's 1, and that's 2, and that's 1. And so our ratio here for AgCl is a 2 up here and a 2 down there. And then we're going to do the same thing over here. We're going to go grams barium chloride and make that moles barium chloride. That cancels those units. And then we're going to get rid of moles barium chloride and make that moles of AgCl. That ratio now is going to be 2 up here and a 1 over here. Now we need to put in these molecular weights. So let me do that calculation. Okay, my writing is getting a little bit sloppy in here, but I couldn't get this in here. This is 169.9 that goes in here for AgNO3, and then 208.2 that goes in here for barium chloride. So now I finish. And for AgCl, what I get here is 0.085 moles formed. And then down here for, down here this becomes 0.144. So limiting reactant is silver nitrate. And I can make a total of 0.085 moles. Now, what we want to know is find out how many grams we can make. So now we take just that number, 0.085, because the limiting reactant determined how much we can make. That's moles of AgCl. Multiply to get rid of moles AgCl. Make that grams AgCl. Put in the molar mass for that, which when I look it up is 143.3. Do the so I do that calculation, and when I do this, this number turns out to be 12.18. That's not right, though. I don't want, that's grams of AgCl. Up here, I don't know where or why, but I got 14.4 in there, and I think when I initially brought this up, that's what the number was. But the number on this problem is supposed to be 10.4. And if you do 10.4 in there and you go through all this calculation, that number turns out to be 8.77 grams is how much you finally make. So anyway, this is how you do the problem. Because it's one of these ones that comes out of a, you know, it's a numbers that change for each problem. When I pulled it up twice, it gave me 2 different numbers. But that's how you do it. And I'm going to stop right there on problem 21 out of 25 and move on to the next one.